Hello guys, this is CodeNCode and this is video editorial for the problem sliding window maximum taken from Leetcode top 100 like questions list. So the problem is clearly hard. And we will be solving of course this using two-pointer solution, and let's see what the problem statement says. So you are given an integer array and you are given a window of size k, okay, and you are moving starting from the very first k elements, you are moving the window towards right, and each time when you are moving the window towards right you have to print the maximum element of the current window. This will be much more clear if I explain this with an example. For example, suppose this was the input, this will be your answer, and how are you constructing this answer is this. First of all, window size is 3, so first of all we'll start with the first 3 elements, and clearly these are the only element that you need to consider, okay. Out of all of these you see maximum element is 3, so you store 3, okay. Then you move the window towards right, now the elements are 3 minus 1 minus 3 inside your window. Out of all of these maximum is still 3, so again 3, then move towards right, maximum is 5, so 5 moves toward right, still we have 5 as maximum, now 6 and now 7. So this is the problem that we have to solve, okay, and these are this is basically forming your solution, and this is you have to return, right? Now the problem statement is clear. What are the prerequisites? You should be comfortable with any one programming language, and you should have knowledge of what are maps or sets, right? How map or hash map work, and knowledge of set, okay, because one of these we are going to utilize in the solution of this problem. Now how we are going to build the solution? We'll be building the solution one by one. I mean, with as always we do, we start with certain observation and then go ahead and build the solution. So suppose this was your input, so we have to ask some question, we have to perform some operations. So we have 3 different requirements. First, we should be able to remove first element of the previous window, right? Because suppose this was my window, when I'm moving towards right I need to remove the first element of the previous window, right? So I should be able to remove first element of the previous window in either constant type or in log n time, okay. By the way, we will be the discussion that we are having, the solution that we are discussing in this lecture is of complexity n log n. You can also solve this problem in linear time, that I'll be explaining in the next lecture, okay. So for now we will be discussing only n log n solution, and in the next lecture we can discuss linear time solution. So think about log n only in this lecture. So we should be able to remove the first element of the previous window in log n time. We should be able to add new elements in the window in log n time. I mean, because when you are moving the window towards right you have to remove the last element and you have to add the next element, right, into your window. Not only that, we also need to find out the maximum of the current window in log n time again. So now think using what data structure we can achieve all of these 3 operations in log n time again, because in this lecture we will be discussing n log n solution, okay. So think about this. So the answer is map. We can use either map or set and perform all of these actions in log n time, right? So we will be using map in this solution, okay. Now this is the input and k is equals to 3, so this is also part of the input, and this is the result vector that we will be building because this is what we have to return, okay. And now we have a map, key of which will be element, and of course value will be frequencies. So in the map I'll be storing for each element what is the frequency. So I'll be storing only those elements which are currently part of our window, okay. So now let's start. First of all, there is a pre-processing phase. So in that phase what you will do, if k is equals to 3 you have to insert 2 elements. Basically if you have to insert k minus 1 element in the map, okay. So first of all I'll be inserting 1, so frequency of 1 is equals to 1. Now I also need to insert 3, so frequency of 3 is equals to 1. Now we have inserted 2 elements, so pre-processing is done. Now we will start looking for each window. The first window start at the third element, right? And that's why we have inserted 2 elements. So the next element that we are going to insert completes a single window, right? So in each iteration what we will do, first thing we'll be doing 3 things. First we will insert the next element which will complete our window. Okay, so I'll insert -1. So frequency of -1 is 1, and as you can see, map actually sorts all of the element based on their keys, right? So they are all sorted by keys. Frequency of -1 is 1. Now your first operation was to insert the element into your map. So this right here, this bracket you see, curved bracket, this element is being represented by L, and this is being represented by R. So the first operation is to insert element pointed by R into your map. Okay, after the second step is to find out the maxima, because now your tuple not tuple, your window is completed. So find out maxima of this. How you can do that? How you can do that, you can find out the last element, because all of them are sorted by keys in the in increasing order. So the last element will represent the maximum element. So how you can get that? So if I show you the code here, first of all, this is the result vector. Okay, and this is the map of int and int, because key and value both are int, and L is equals to 0, R is equals to k minus 1. Okay, because we are working with zero based index system. First of all, what we did, we inserted all elements into the map, only single, doesn't matter actually. So only inserted all of the elements till k minus 1. Okay, I mean k minus 1 element we have inserted already into the map. So this is pre-processing part. After that, you have to perform iteration till R is less than n, right? Because R represents endpoint of your what we say window. So when R is equals to here, it represents this window. Where R is equals to here, it represents this window, and so on, right? So first step you do, you insert current element into the window. Okay, that's exactly what we just did. We incremented the frequency, basically inserted or updated frequency of -1 into the map. That is being done here. After that, what you'll do, you'll find out the maximum element. How? You can find out, or you can call the function rbegin. So in map or set, begin returns the first element, and rbegin, or basically reverse, rbegin or rend represents the last element. Okay, so rbegin will return you the last element, and it returns a pair, because key value pair, right? So first element of that represents actually your value, so maximum value. Okay, so that's why in the result we are inserting max dot first. Okay, after that, what you will do, you need to move your window towards right. So for that, so this max returns your, this step we have already done. Max is equals to 3 1, this one, and inside your result you will insert max. Okay, after that, what you do, you have to move your window towards right. So to do that, you need to remove frequency of element represented by L, basically first element of current window, which is 1, which will be represented by L, by the way, right? L represents starting, and R represents ending of a window. So you need to remove the first element of the window. That's why I am removing the frequency, basically reducing the frequency of element represented by L, basically the first element. So if frequency becomes 0, that means this element does not exist in our window, right? So we will simply remove this. Okay, that's exactly what is being done here. If frequency of element represented by L is 0, simply remove it. Okay, after that, of course, you will increment your L and R are both being incremented at this point. Okay, because of this inside for loop, L and R are both being incremented. So now R actually represents this. So again, what is the first step? Again, add element represented by R into frequency array or map. So frequency of -3 will become 1. After that, what you will do, you will find out the max, which is again 3 1. So you will insert 3 into the result array. And after that, what you will do, you will reduce frequency of element being pointed by L. So frequency of 3 will become 0. And after that, you will simply remove that element. And the same process will keep on, you will keep on repeating until your R is less than n. After that, we would have already tested all of the windows, and you have the result. Okay, after that, all you have to do is return the result. So yeah, this is how you solve this problem. If you still have any doubt or query, you can ask in the comment section. I'll be providing this solution in the description of the video, so you can use it as a reference. So yeah, this was all for this lecture. Thank you guys for watching, and until the next video drops, keep coding. Thank you.